Today we're going to be teaching how to convert polar coordinates into rectangular coordinates. So to begin, we're going to show the difference between rectangular coordinates and polar coordinates. As you can see, the rectangular coordinate has the points x, y. So if you were doing that on the graph, for example, if we had the point 3, 5, on the graph, what you would do is go over 3 spaces and up 5 spaces. Now to the polar coordinates. The polar coordinates is r theta, which is equal to the radius to the angle, which is theta. So if we had 2 pi 6, we would have to go to the radius of 2 and the angle of pi 6. So this is the difference between rectangular coordinates and polar coordinates.
These are the two equations you should familiarize yourself with to learn how to convert polar coordinates to rectangular coordinates. So for your x equals r cosine theta, and you simply plug in your r value and your theta value. And for y equals r sine theta, and you also plug in your r value and your theta value to figure out what your x and y are.
Now we're going to convert the polar point 2 pi halves to rectangular coordinates. First, we're going to identify the radius and the theta. And we know that the radius equals 2 and the angle, or the theta, is pi halves. Now we're going to set up both our equations to solve for x and to solve for y. First, we're going to solve for x, and we're going to do this using the formula x equals r cosine theta. Now we're going to plug in 2 for r and pi halves for theta. Now, we know that cosine of pi halves equals 0, so we're going to plug that into the equation. Now we solve for x, and we know that 2 times 0 is 0, so x equals 0. Now we're going to set the other equation to solve for y, which is y equals r sine theta. Again, we're going to plug in 2 for r and pi halves for theta. We know that sine of pi halves is 1, so we're going to plug that into the equation. And we know that 2 times 1 equals 2, so we know that y equals 2. And now we have our rectangular coordinates 0 and 2.
To prove that polar points and the rectangular points are the same, graph the point 0, 2, which we just found. Now, as you can see, this is our polar graph. Putting the polar graph on top of the rectangular graph, you can see that the points 0, 2, and 2 pi over 2 are the same points.
Okay, so we're going to convert the polar coordinate 3 root 2, pi fourths to rectangular coordinates. So first we're going to identify what we have. So r equals 3 root 2, and then theta equals pi fourths. So we're going to use the equation x equals r cosine theta to figure our x coordinate, and then we plug in r for r and theta for theta. So now we have x equals 3 root 2 times the cosine of pi fourths, and then x equals 3 root 2, and the cosine of pi fourths is root 2 over 2. So now we have 3 root 2 times root 2 over 2. And then that equals, we're going to simplify that. So 3 root 2 times root 2 over 2. So 3 times root 2 equals 6. So now we have 6 over 2. And 6 over 2 equals 3. So now our x-coordinate is 3. Then we do the same thing for our y-coordinate. So this time y equals r sine theta. And we do the same thing, plugging in our r and theta. So y equals 3 root 2 times sine of pi fourths. And then the sine of pi fourth is also root 2 over 2. So we have the same equation. Root 3 times root 2 over 2 equals the same thing. 3 root 2 times root 2 over 2. And then y equals 6 over 2 and y equals 3. So our final rectangular coordinate is 3, 3.
Now we're going to convert the polar coordinate -3, 11 pi 6 to rectangular coordinates. We know that r, which is our radius, is equal to -3, and theta, which is our angle, is equal to 11 pi over 6. To start, let's find the x-coordinate using the equation x equals r cosine of theta. So since we know what r and theta is, we're going to substitute those into the equation and get x equals -3 cosine 11 pi over 6. Cosine of 11 pi over 6 is root 3 over 2. So now the equation is x equals -3 times root 3 over 2. So our final x-coordinate is x equals -3 times root 3 over 2. Now moving on to our y-coordinate. We're going to use the equation y equals r sine of theta. Once again, substitute r and theta into the equation and get y equals -3 sine 11 pi over 6. Sine of 11 pi over 6 is equal to -1/2. So the equation is now y equals -3 times -1/2. And so this would make our final y-coordinate 3 over 2. So our rectangular coordinate is going to be -3 root 3 over 2, comma 3 over 2. Thank you for watching. Please like and subscribe.